Okay, welcome everybody to this workshop on roles and responsibility of an SRE engineers. Okay, well friends, we will do a quick round of introduction and then we'll take this up. Okay, let me introduce myself, friends. My name is Roshan. I have overall 18 years experience in IT. I started my career as a Java developer, and then I have been into various SUS. I have been system admin, network admin, right? Currently, I'm working as a principal SRE. I have spent approximately 6 years as a performance engineer, uh, hardcore performance engineering, right? Been into DevOps consultant as well. And I'm with one of the reputed giants of the retail company in the world, right? So that's a background about me, friends. We'll have a quick introduction of ourselves and we'll understand about the aspirations. I'm going to definitely make sure that we have some learning by the end of the session, right? We'll answer Q&A. We'll understand more about this profile, the SRE engineers today. Yes, let's start. Brijesh, you would like to get started?
Yes. Hi team. And I'm Brijesh and I'm a lead production engineer at Sclera. It's IT company. And I have around 6 years of experience and I'll be leading both production and QA teams in this company. So basically my work will be like monitoring and providing RCAs, spinning up servers and leading a QA team as well. Yeah, that's my just a quick
Good.
intro from my yeah.
Good, Bridges. Good that you already have experience of production. I'm gonna come to
Yes.
that. That's in the role of SRE engineer, how production play an important role. And when we work in non-production environment, it's a different challenge. In production, we need to be very alert. We have to be proactive, and we have to maintain the SLAs of the production, be it uptime, response time, throughput, a lot of factors, right? So it's a different challenge, and that's what
Yes.
SRE offers. We will get to that. Good to
Sure.
know about you, Brijesh.
Yes. Thank you.
Yes, Shivamani.
Hi, good evening. I'm Shomani. I'm working in one of the leading bank company. I initially I joined in the operations team. So recently I moved to the technology team as a manual tester. Now I would like to enhance my profile to the technical side of profile, like anything on the production support side, otherwise in the DevOps side or the developer side. Before I move to my profile to there, so I want to understand how it is, what are the roles and responsibility. So I thought to have this session will help me to understand what how that profile would looks like. Either can be accommodate myself or where I need to enhance from the knowledge perspective, as well as I need to look for that balance between the family as well as the work life. So that is the reason mainly I joined for this.
Good to know, Shivamani. Yes, in as an SRE engineer working in production, sometime yeah, work life balance does take a hit, and we have to be available. We don't know when the production issue
Yeah.
we can encounter it. So and we have to be available, and particularly when you're leading a team, definitely it's
Mm.
required.
Yeah.
So
Okay.
yes, it's one of the things challenges that we need to address, or we need to understand.
Exactly.
That is one of the things we will
Okay.
get to. That how can we make sure, so why can't we make the application in a way that it's self-healing, right? We should
Mm.
get towards that. As soon as issue
That's fair
comes,
point.
we have some automation scripts which senses the problem incident and have some automated script, and we can resolve that. So we have this agentic AI, we can write such things. We'll get to that. But for that also we need a deeper understanding of the application, um, alerting, right? Alerting, having
Mm.
the SOPs defined, standard operating procedures defined for a particular alert, what needs to be done. So anybody working in the shift can do the initial analysis, and when things are beyond control, yes, a senior person can be available, will be can take this up. So we have to plan the production incident in a way. Yeah.
Yeah. Okay.
Perfect.
Yeah.
We'll discuss more on that, Sivamani.
Okay. Thank you.
Perfect. Good to know. Yeah, Nikhil,
Yeah, hi.
I'm just
So myself, Nikhil, I have like 5 years of experience as a performance tester, and recently on a couple of projects I worked as a performance test lead as well. So I have experience with scripting tools, LoadRunner, and APM tools, namely Dynatrace, AppDynamics, and Datadog. And yeah, so I'm working in an highway toll company, 407 ETR International in Canada. So yeah, this is my experience. And recently, I realized that few of my senior performance test engineers, or like they worked as leads as well. They moved into SRE role. So and and I see that uh, performance testing positions are limited to only like bankings or insurance domains, or it's like companies where is a huge amount of traffic on their applications. So it's specific to only big cities. That's what I observed. So I want to move to a small city and saw that SRE roles are available in companies in smaller cities as well. So and yeah, that is one of the main reason. And like having seen few of my senior testers who worked performances who worked with me going to SRE
great.
roles. So all these things gave a thought to look into what is SRE exactly.
Right. So
And
definitely, Hemant, one thing is that as a performance tester, because I have been a performance tester engineer myself, so I can comment on that. Because the experience that you get, right, the troubleshooting experience that you get, the load simulation part that the skill that we get, because to make sure that we don't get issues in production, we need to simulate prod load in lower environment, right? And we understand, let's create load like prod or situation scenarios like prod in lower environment, and let's understand this issue so that we don't have to face this issue in prod, right? And the definitely, so it's a gradual, right? It's a very organic growth that I see. Even I've seen many of my colleagues doing that, and it's a very natural thing to move into SRE, because SRE role gives you more challenges. Being a performance tester engineer, you work in a lower environment, and how much ever we try, we cannot replicate the entire prod scenario. So we do encounter production issues, uh, which we have not seen or observed in lower environment, and we need to tackle that. And that's the skill, and it's a pressure situation because things are not working in prod, and we need to resolve it. Think about if a retail company like Amazon or Flipkart um, is down or having some issues with response time, or status code not being successful, we are getting 5xx 4xx, it will lose business, right? It will lose revenue. It becomes so critical to make sure that we are highly available, reliable, secure, right? Cost efficient as well. We cannot just, so we have so many factors, roles and responsibility wise as being an SRE engineer. We'll get to that, and you will learn a lot here. I can tell you that. Good to know about you, Nikhil. Yeah, Hemant,
Hi, I'm Hemant. I'm working
you
as a
are
performance.
fairly audible. If you could
Okay,
be
yeah. Is it better now?
somehow, you need to. Looks like you're speaking very far from your mic. Okay, go ahead.
Okay, yeah. I'm Hemant. I'm working as a performance test lead for one of the incidents frame. Just want to upskill the SRE skills actually as part of my career. That's main thing. And even yeah, the same thing. Whatever the Nikhil said, even my all my colleagues, yeah, performance colleagues, they started working as a SRE. I don't know how they migrate. I just want to see the difference in terms
No,
of
it's
the
organic.
performance.
It's an organic development,
Ah,
Hemant,
okay.
because I'll tell you, because being a performance tester yourself, you understand the architecture of the application. You need to understand, right? To troubleshoot any application, you need to know the architecture of the solution. You need to understand all the technology involved, all the layers that you have: web server, app server, database server. You already know that, and you have troubleshooting experience. Let's say your response time is high. You need to do some analysis before you take the issue to the developer. You cannot just raise a bug. Okay, I'm getting this issue. No, you have to deep down. Where is the problem? Narrow down, and then if it required, take the help of the person who has ownership of the code, right? So we can take that issues. But the troubleshooting part, the observability part, because we need to also monitor things, systems when we run a performance test. It's like a load test. It's like a prod scenario. You can simulate prod load and see what's happening before you deploy the code to production. Why can't you simulate the load in lower environment and see what's happening? So that's why the performance engineers testers are very much likely to get to SRE engineers, even people, because there is no skill as such SRE engineer. Either a DevOps engineer could be an SRE engineer working in production, like Brijesh, right? He's into production support, right? So either you need to be a DevOps engineer or into operations or a performance engineer. These skill only can make as a SRE engineer. You need to have the deployment knowledge. You need to have the troubleshooting knowledge. You should have the observability monitoring knowledge. How do you at least see the graphs? How do you understand those things? CPU memory. And as a performance engineer, we do understand these things. That's why it's an organic development to become an SRE engineer for a performance engineer.
Yeah, fair enough. Yeah, thanks.
Right. Okay. Good to know about you, Hemant. Mohan? Okay, Mohan, if you can hear me, we'd like to know about you. Okay, I'm not sure. Maybe Mohan may have some issues. Okay, Dharmendra, you there?
Can you
I
hear me?
hope. Yes, you're audible. Go ahead.
Yeah, this is Dharmendra. Hello, everyone. And yeah, so I started my career as performance tester and then moved to performance engineering. Then worked in DevOps for quite some time. So now I am exploring whether I'm fitting in SRE role and wanted to learn and get more idea about how things work as in SRE domain. Yeah.
Definitely,
So
good to know, Dharmendra. Yeah.
so yeah, sorry.
Yeah, good to know that, because these two are the most important skills who become SRE engineers. The DevOps, having the understanding of the deployment, how the applications are deployed, automation in an automated way manner, rollback, understanding of Kubernetes or VM, the way you deploy, and the troubleshooting mindset of a performance tester. And these two, along with some automation, is what will becomes SRE engineer. So we will go towards that. Okay, good to know about all of you. Perfect. So let's understand this. See, what is the roles and responsibility? So when I say roles and responsibility, we need to understand that SRE engineers and DevOps engineers, there are three roles. Performance testers engineers. We have been talking about performance testers engineers. We had DevOps engineer. And we have, let's say, production support, who are into at least production support, doing and well, because see, if you look at SRE or organization for any company, you will see multiple levels: L1, L2, L3. L1 are the ones who work like in shifts, because see, company like Amazon, Flipkart, retail companies particularly, or any other company, those who want to be highly available all the time, and and if they want to really serve the customers well, they need to have somebody in the system, right? Looking into the system, if there is any problem or not, right? Because we cannot afford downtime. AWS had a downtime sometime back near Diwali, right? So we have to be alert all the time, because the issues may come. And if somebody is doing a proactive alerting, proactive monitoring, we can find the issue early and we can remediate that so that the real customers won't be impacted. So we have to be, uh, somebody in the organization has to be looking and take appropriate action. So we have various levels: L1, L2, L3. L1 are the ones who work in shifts 24 by 7, right? So let's say 8-hour shift, and they would know what needs to be done. They would look at the monitoring dashboard. They would have the alerting set. They would get alerts. It could be in the pager duty, or it could be in the Teams application, could be so many platform. You can get the notifications for any issues. Basically, let's say these issues could be any type. Response time is high. CPU, based on the alert that you have set for a particular metric, for any metric, right? Say you have CPU, memory, these are response time, uptime. These are very important metric, and these metrics has to be monitored 24 by 7 for a company. If uptime is failing, means you're having a downtime, and you will lose business, you will lose revenue, you will have reputation, right? A lot of things at stake. To think about it, you open a Swiggy application and that app is not working. How would you feel? How the reputation would go? And the competitor is working fine. So definitely they will lose a lot of business reputation, and definitely people would have the option and they would go with Zomato, right? I'm just giving one example. Same thing you can consider for other applications. So we have to be, and if you are, let's say the anybody has opened the application in the mobile, and you give the best experience from the user interface, from the performance, from the ease of use, no problem. The customers like it, people like it, even if the other applications are good, but since you had a good experience, you will stick to that. It's kind of a human nature, right? So that's why it's so important to give the user the best experience. And how it is done, it is done by a team, by working 24 by 7. They need to be alert, they have some SLAs to meet on the response time, uh, on the CPU utilization, everything, right? On the uptime. So we have a lot of metrics that we measure, right? If I have to just list the metrics, it could be uptime, one of the very important metric that any company has to measure. And if you have a problem with the uptime, somebody has to take up that issues at the earliest. We can have some metric on the response time, because the SLA, if you use a retail website, the response time is, we expect very fast nowadays, right? We don't expect the response time in 1 second. If I open a page, I would like just in millisecond. We are so, our fingers, right? If you look at the human nature, we want the application to be super fast. It's been millisecond response time. And how it is done? It is done through a proper architecture. And if that's not meeting, we have to do something about it. If not, the company would lose people, revenue, reputation, a lot of things. Uptime, response time, status code, right? 200 status code is good. If I'm not getting 200 status code, let's see if I'm getting 4x's or 5x's, that's not good, right? For a company, it means that orders are failing, transactions are failing. We have to be on top of it, right, to fix that. Same thing goes for all the server CPU, memory, process level CPU, memory. Uh, if you're looking at the database, we would like to know about the how my read latency is happening, write latency is happening, how my IOPS is working. Looks like if it's a Java application, we would like to know how my heap usage looks like. If the GC is happening, do I have memory being retrieved or not, right? How the GC is being performed. Do we have any contentions on that, right? So depending on the tech stack, we need to have the right metrics for all the technology, and we need to be keep monitoring. So it's if I give you thousands of dashboards, right, it's practically not possible for anybody to keep looking all the time. So what do we do to get to know about the issue when it comes? What we should do, friends? Alerts. We should set up alerts. That's the only way. And you can set up some proactive alerts, and it has to be monitored by a team, because nobody can look into 200 web dashboards that you have created across multiple applications, right? So we need to be alerted. And when you get the alert, it has to be with some severity, priority. If you get an uptime alert, it's a P0, it's a priority 0. You have to attend that at the earliest, right? If the response time you have given, response time, let's say, for example, you are catering all the response time, let's say in 50 milliseconds. But now response time has become 100 milliseconds. That's fine. Not users are not feeling, you're not getting 5x6, you're not getting status code, but it's a problem, right? The user experience would be bad, right? The user's page load, API, if the API response time has decreased from 50 to 100, it's 100% degradation. We have to look into that, and we should know how do we look, where is the problem statement. We should be knowing it. Does it infra issue, or what is the issue? Are we getting more requests? Is my infra whatever configured is not enough? So there could be a lot of factors to troubleshoot it. And we are talking about prod. We are not talking about a lower environment where you test it and you're getting it. So you have time. No, in prod, you have to fix that issues. And that is what being challenging and rewarding. That's why people, every company look for the SRE engineers, that people join SRE team, they set up alert, they set up dashboards, and they make sure that they meet the SLAs, right? And for so many metrics that we have mentioned. So that's why performance tester engineers have the right skill to be upgraded or to transition to SRE engineers, because as a performance tester engineer, as I was telling, you do simulate load like prod, and we do try to create a prod like scenario, at least the load part, and we see how my application is performing. But prod is a different ball game. There could be various kind of issues. Abrupt hits can come. One server can go down. We have to address through chaos testing, right? Because prod scenario, we cannot replicate everything that happens in prod. Prod is the real user experience. How much we try to simulate, we cannot replicate everything. So we have to think about it. What all could be simulated? So we have to simulate, we have to do our best and see the metrics. And we do get the confidence after a couple of runs. If you have run 1.5x or 2x of prod load, and you understand that you have reliability in place. So you do get the confidence, and you deploy your application code into prod, and then you observe the behavior, right? As a DevOps engineer, DevOps engineer are very much good at the deployment of the code, which, let's say, developer has written a code, could be a bug fix or new enhancements, and we need to deploy that code in various environments. So DevOps engineer's primary role is to code deployment through automated pipeline. There could be other roles and responsibility as well, and a lot of things gets overlap. As I told you, performance tester work and SRE works get overlapped. I'm talking about the L2 role. Okay, as I told you, there are 3 roles of an SRE: L1, L2, L3. L1 are the ones who work in safe 24/7, and they keep an eye on the performance. They keep an eye on the overall health of the application, and they look at the alerts that they are getting, and they act on it. And how can they act? And these are not they could be technical also, and if they're technical, they're good. If not, L2 engineers, some senior SRE engineers, is what we're talking about. We want to become this L2 here, and they can help write some SOPs. We call it system SOPs, right? We need to know what needs to be done. If an issue comes, standard operating procedures, what needs to be followed. Let's say if your response time is high, what an L1 engineer should do. L1 engineers are like 2 to 5 years experience, 2 to 5 years of experience, and they join L1 engineer, and they know how to deploy the application. They know how to capture a metric, how they know how to take up the logs. They're very much good at these things, right? And they know what if the alert comes, what needs to be done, because they have been given instructed through SOPs. And basically the L2 engineers who understand the application, they have to help writing the SOPs. If this issue comes, what needs to be done? If CPU is high, what needs to be done? If the pod or the server restarts, what needs to be done? Right? So that they collect the evidence, and if still they persist, they have to get in touch with L2 person, and things would go on. Now, L3 are the subject matter expertise. L2 engineers are good. So the senior performance engineers or a senior DevOps engineer having minimum 5 years experience, they can be L2, and they need to help L1 engineers writing with the SOPs, they're senior person. But again, they have some skill limitation. They cannot be an expert in the application. The L3 are the developers or the product owners or the expert, subject matter expertise, SMEs. And if things are not beyond the scope of L2, we need to get in touch with L3. So that's the hierarchy usually we follow in an organization of an SRE. Right. So what is the role? So what basically needs to be done as an SRE engineer, L2 engineer? What is your goal? Our goal is to make our application running in production highly available. That's one of the first important. The application has to be highly available. At least if anybody hits the website, that we should get response. It should be up and running. We should not be down. That's first priority. It has to be highly available. Now, if it's highly available, obviously it has to be performing. It has to be highly performing as per the SLA that we have defined. Basically, it's all about the user experience. You need to understand your user. Now, it depends on the user. If you are working on a banking application, the user experience could be different. If you're working on a retail website, the user experience could be different. Right? So you need to understand your user, and you have to give the user the best experience. And obviously, the competitions you have to be better at than them, right? So user experience is what matters for the SRE engineers. We have to give you the best experience from availability perspective, from the performance perspective, from the application website usability perspective. We have to be secure. How much ever available and highly performing application is. If the application is not secure, is it good? We provide our personal details, our credit card details, debit card details in a lot of websites. If you see Swiggy, Zomato, right, Flipkart, Amazon, we do tend to save our credentials, credit card information, debit card information. We do tend to save, and personal information, address, we always provide, right? Think about it. If the application is not secure, somebody can hack and get your details and can misuse. So security is very important. And we're talking about production here. It comes under user experience, security. So we need to also be very much vigilant about security. People overlook security, but it's very important. The most important thing. Your customer may be unhappy if you are not available, if you are not performing. but they will not tolerate security breach. Nobody tolerates security breach. If you are paying, if you have paid, if you're paying for the subscription, let's say you have taken Workday or Salesforce subscription, you're paying monthly, and you have onboarded your all the company employees, and it's not secure. Think about the situation. You're gonna sue, definitely, right? Security, right? So high availability, performance, security, reliability, right? One of the very important word that we have is reliable. What is reliability? See, issues will happen. How much ever we try, even Google, Amazon, AWS had a downtime. Every company can have a downtime. See, issues will happen, failures will happen, but how soon you recover? Do you have automated way of recovering yourself? How soon you recover? That's reliability. Are you reliable? Issues will happen. Your server will go down, your load balancer will go down. You cannot trust 100% on anything. Will you be reliable? Is your application reliable, robust? That's reliability. And the entire solution, right? It has to be cost efficient. I just cannot create a website or an application beyond where the company is not getting the margins. It's not going to be, it's not going to be, it's not going to fly, right? It has to be cost efficient within the company budget. It has to be cost efficient. Then only you gonna get value for your idea. So if you ask me as an SRE engineer, what should be our focus? This is the focus, and everything is around that. You need to be highly available. Now, how can I be highly available? That's again a deep discussion in itself. Now, how can you define availability? Now, think about it. Let's say you have a 3-tier application. Let's say you have a web server, app server, and database server. Let's say, let's draw this. Let's understand these terms. Okay, let's say you have this web server. Let's say you have this. Let's say you have this app server, web server, app server, and database server. 3-tier applications. There could be more layer also, but I'm just keeping it simple. Web server, app server. I have only one server for each one of them, right? One for the web, one for the app, one for the DB server. Now, do you say this is high availability? Have you taken care of high availability here? Can you say that? Can you make that statement?
No, I think so. We have to make sure it's when unexpected load encounters, it should be even even in those cases, the application should be available. So it should be auto scalable.
Yes, definitely auto scalable because the load may increase. And if the load increases, we have to make sure that we get additional VMs, right? Right now, I have just one. Don't you think we have a single point of failure here? If web server goes down, do you think I'm going to have a downtime?
We usually have that DR server, right? When we are talking about the production, we usually have some.
We'll come to
DR.
the DR. Shivamani will come to the DR. Forget about it. I have only one web server. Do you buy that statement first of all? Are you good with this? Are you happy with this setup? Let's say I have a DR also. Fine. I'm okay. Let's have a DR also. Then are you good with that? In DR also I have 111. Are you happy with this? Is it enough? This is DR. DR is about, that's what? DR, we talk about disaster recovery when you have a complete failure. First of all, why do we create that complete failure so easily? If my web server goes down for any region, I have a complete downtime. So it's not a good way of infrastructure creation, right? We have not taken care of high availability. At least 2 servers minimum for each is what is definitely you should keep it. Like I'm just giving the bare minimal thought. Minimum 2 servers for each one of them. So that even if one goes down, I don't get a downtime. Do you agree with me, everybody? At least for the web server, database server is challenging. So we should have a standby database here. We cannot create a 2 database like web server and app server, because database replication will also play a role. So we should definitely have a standby database also. If my primary database is down, I should go to the standby database. Like now, do we all agree with this statement? That minimum we should have 2 servers for each component. Yes or no?
Yes.
Yes.
Minimum. And definitely auto scaling is definitely required, because now if this is down, I may talk about my DR. That's absolutely fine. Yes. If my this is down, total is down, I'm not getting downtime. Yes, we should switch automatically. The traffic should be routed to DR environment. It was routing to primary. Now we have a DR setup, but at least minimum 2. So for that to happen, we need to understand now the deployment is happening in the cloud. Deployment nowadays is happening in the cloud. So we should know cloud. Do we know how do we create servers? Like the understanding of cloud is very important. Without understanding of cloud, we cannot create servers. We should understand in the cloud, we have a concept of availability zones. We have a concept of regions. We need to understand how much core we are giving, how much cores and RAM instance type we call it to a server. How much is the load we're gonna expect in production? How can we do auto scaling? And obviously the load balancing. So do you think we need to have this much knowledge to even talk about high availability? Minimum from the infrastructure perspective. I'm not going to the code level. I'm not talking about monolithic and microservices. At least from the infrastructure perspective, we should definitely understand this. Then only we can talk about anything on this. Yes or no? Do we all agree?
Yes.
For that, we need to know cloud. That's so prerequisites are there. Okay, to become an SR engineer, there are prerequisites. Anybody can become SR engineer, but we have to understand these things. Why these things are important to know? Because if you do not understand how do we create server, core, RAM, these things, load, TPS, like a performance engineer understand these words, load, TPS, response time, but that's fine. Overall load. Even a performance engineer, when they test, one of the role of a performance engineer is to do capacity planning. One of the important role of a performance engineer is to do capacity planning, because they are the ones who simulate the prod like load. If I have to ask a team how many servers would be required in prod, who should we ask? What is your understanding? Who should we ask? How many servers should we deploy for web server? How many server for app server? Who should we ask in a company? Is it developer? Is it architect? Is it ops guys? Is it QA team? Who should we ask this question? The person who is simulating the prod load. Yes or no? And who simulates prod load? Performance tester engineers. Because they know how much server would be required. They may not, let's say, they may not get infra to simulate entire prod load. Okay, 10%, 20%, 30%, whatever they know, and they can extrapolate and give a suggestion. Okay, let's say you simulated 20% of the load, and you required, let's say, 5 VMs. Now you know to simulate 100% of the load, how many VMs will be required? Yes or no? And we can give some extra 1 or 2 some buffer. We can have auto scaling configured, and you're good. So we need to have that kind of understanding to even talk about high availability. And from the infrastructure perspective, nothing else. Right. Now, coming to the second point, high performance. How can I achieve? See, performance engineers test. They test. They simulate the load and they inform. They come to know about the current performance. Now, let's say the performance is not up to the SLA. Let's say your SLA was 50 or 100 millisecond, but right now the response time is 300 millisecond. Now you have to optimize it. So we should be in a position to know where is the problem. Is it database problem? Is my query taking longer time? Is my code taking longer time? Logic? Or is this infra not enough? Is the problem with the code or problem with the infra? First, we need to understand this. Let's say you understood there were no problem with the infra, there's problem with the code. Okay, so is query taking longer or code taking longer? If a query taking longer, so we should be in a position to know. And how can you know about those things? When you have the dashboard with you, you should have the metrics with you. Should have some monitoring dashboards. Then only you would know. You would go and check the response time of if you look at the Dynatrace or AppDynamics, we get to see a lot of good details. If you check any transaction, you get pure path in Dynatrace or a lot of tools they provide. We understand the problem now. Then we can take that to that query. We can talk about query optimization or have we done index. So we should understand basic stuff in database. What all could be the problem? Indexing could be the problem. Somebody has missed the indexing. We can take up that, or the query itself taking longer. Somebody has written a bad query. Select star from a table, and that table is big, billions of records. The person who has written the select star has not thought about the performance. They are simply written select star, and then they're using few columns after that. Why do we do that? If you have such a requirement, take only few columns, select this column and this column, and get your work done. Why do you select star and my database is choking? So query could be a problem. Indexing could be a problem. So we should know the problem. Where is the problem? If the code is taking longer, okay, somebody can write a bad code, taking longer time, unnecessary for loops. Just to, because if a new developer, that's the difference between a beginner developer and expert developer. A normal developer just will try to make sure that the application works. And junior developer will not think about how much resource, how much processing power, how much memory that piece of code is taking. Okay, just the developer focused on getting the implementation done. But that's not we are talking about. We're talking about making the application efficient. We need to make sure that the code takes less CPU, takes less memory, and get work things done same way. So there could be a lot of problems. So if that problem is the code, we can talk to the developer. We can show him that this particular method is taking longer time. We can work with them. We can see how can we optimize it. So performance. Now, if let's say the infrastructure was problem. Let's say core query we talked about. Let's say but the infrastructure was the problem. So you have to make sure you give the right infra. Let's say you knew that for 100% you require 25 VMs, but you have given only 15 VMs in the prod. What will happen? You will get 5x6, 4x6 response time high. You'll get all sort of failure. Friends, I hope you're able to understand these problems. These things are very common problems. And people do not, if the person with basic understanding, if you understand this can be resolved. Now, there could be a lot of things, let's say a retail company, they don't expect the performance to be in 400 milliseconds. We want 2-digit millisecond. If I search my order, friends, if I go to Flipkart, if I search my order, try to describe the product description page. If I want to select an item, I want to display, I need this page to be loaded immediately with me, right? I don't want to delay. Look at this fast, how fast, because they have cached it. It's not, if this transaction will go to the database, it will take longer. They have cached everything. They are using in-memory database. That's why you're able to see so much of fast information getting displayed. And think about it, if this page takes longer, would you be interested in this website? Let's say this page taking longer. Okay, you're still waiting. Okay, then you would key, instead of waiting, you go to the other website and get you order, right? This happens. So we have to be, these things are so important for the business. So we have to talk about caching. How do you cache? How the caching improve performance in memory database, right? So we have to understand everything, friends, and these things we should, as a SRE engineer, we should know these things. Now, security. I told you, right? If you are not available, if you're not performance, okay, you may lose business, you may lose revenue, but if you're not secure, you may get sued, right? Because you are not just, it's not about just you, but the information that you're hosting in your application. Security. So we have to know. So we have a lot of security services in cloud, right from who all can access the server, who all access the website, which ports are open, how do you protect DDoS attack, how do you protect web application firewall, exploits, how do you make sure you do private connection, not via public. So everything we have to know for security. And again, the understanding of cloud is very important. I have opened cloud. I take up a course in SRE. I'll talk about that. We take up through AWS, and we have a lot of services in security. And cloud provides a lot of security services. If you look at this, we have so many security services. Why do we have so many security services? Guard duty, IAM, inspector, Messi, secrets manager to store credentials. Because if you do not think about security, friends, it's very important. And we need to understand the networking from the VPC. So everything, how the communication happens between two servers, how web server and app servers are communicating. Have you opened all the ports for the web server? Have you opened all the ports of the app server? Is your app server publicly accessible? Is your database server publicly accessible? So these things do play an important role in the security. And we should have that basic understanding. If I talk about SRE engineer, we should know, being an L2 engineer, should know basic understanding of security and the importance of private connection. No server should be publicly accessible directly from the websites. Everything should be happen through load balancer. When you hit, I would just keep it this way. When you hit Flipkart.com, what we actually hit? It's a Flipkart, it's a domain name. We hit domain. Then domain server routes, resolves our request, and our request goes to the load balancer. And load balancer sends our request to the web server. Web server talk to app server, app talk to database server. we don't hit web server directly. We cannot as a user. We hit load balancer we can reach out to, and that to load balancer we will have a proxy will also. Nobody can directly hit the load balancer. You hit the proxy. So security is very important. Right from you hit the application from your browser and how the request is being traversed, who all can access, because we don't want the application to be hacked, right? And we have a lot of security services which cloud offers. So security is very important. Reliability. See, failures will happen. Just now, we talked about auto scaling. What is auto scaling? If a server is down, let's say you have some problem happened, some failure happened, a server goes down. And the load continues to same. If server is down, obviously the load would come on the remaining servers, which is not enough. So servers need to auto scale. What if load balancer is down? Gets down, right? Do you have DR setup? Primary cluster entire down. Do you have DR setup? So everything comes under reliability. We need to think about creating some sort of chaos in the application, some sort of chaos, injecting immense load to check auto scaling happening or not, or how long it takes. Putting immense load and check how long it takes to auto scale. And if it takes longer to auto scale, then you will get 5x's for some time. So you can remediate that. What if a few servers goes down? We'll have some performance issues, status code problems. So you have to fix that. What if other component goes down? What would you do? What if the entire primary goes down? How long it takes for the DR to become up and running? Does it come automatically, or how long it takes? How long the application will be down for the users? So we have to talk about these things in reliability. And obviously the cost efficient, friends. If I give you a solution, but if I don't talk about the the effective way, cost efficient way, it's not going to fly, friends. So all these things play a very important role for the SRE engineer, and we deal with production. That is the most important thing being an SRE engineer. So friends, just to, okay, any questions so far? Okay, are we good, friends? Are you with me, everybody?
Yeah, Roshan.
Yes, sir.
Perfect. Okay. So now, if you are looking to be an SRE engineer, friends, I can help you. I have a course with ESA I'm running this course from last 5 years now, 6 years. Yeah, 6 years. I'm running this course with ESA. You can go over this course, friends. Right. And I'll just walk you through this course content. We'll have a separate demo session, friends. We'll have a separate demo session about this. We'll have a separate demo session about the course. I'll talk more about the course perspective, but I'll just tell you what all we cover in this course. You can check these things. I have taken a few demos earlier. I'll give you this link. Let me give you this link first of all. You can go over that and feel to attend the demo session, which is scheduled next Saturday, friends, 7:30 p.m. next Saturday. Demo session is there. Feel free to attend. I'll talk more about the course. You can ask me more questions about the course. I'll just brief you today about the course. We talk about cloud. Very important. And we cover in depth. And whatever we do, right, we cover from scratch. I don't expect. So if you already know cloud, you may think, okay, I am repeating, or you know things already. I'm just giving you a disclaimer because I take up it from scratch and I understand that my audience doesn't know about cloud. Okay, that's how I take it up. Cloud, right? Now, before I talk about my next topic, We talk about Linux. Can anybody tell me why Linux is so important to know? I would like to know from you. Let's say those who are working in production and having DevOps background, performance engineering background, why Linux is so important to know? I would like to know from you. Okay, do you agree Linux is mandatory to know?
Yeah, mainly because 90 or 99 or maybe more than 95% of servers are based on Linux in production.
Absolutely. Absolutely, Dharmendra. Whatever we are using, right? We use Flipkart, Zomato, Uber, whatever application that you see, it's all on Linux. It's not on Windows. And if the issue comes, we should know, we should be able to troubleshoot issues. We should be able to go inside the Linux server and practice and understand those issues, troubleshoot those issues. So we should be very much comfortable with Linux. And over the years, I've understood that not most of us are comfortable with Linux, particularly because we don't get exposure on these things. So that's why Linux, we have kept it, friends, in this course. We talk about SRE, what is high availability disaster recovery, SLAs, SLOs, SLIs, how do you manage one incident, SA complete SRE thing. We talk about architecture of the application, monolithic microservices architecture. We talk about containerization. See, because nowadays, if you see, okay, I'll again ask you this question. How many of you, I just want to know yes or no. I just want to understand what's happening in the world around me. Where is your application deployed? Is it running in the VM or is it running in the container? I need everybody to answer this question in the chat. I'll take a count. Do you know, first question, do you know whether your application is running in the VM or running in the container? That's question number one. Do you know? Yes or no? That you need to answer in the chat. Second.
Yes, it is container. It is in container,
Okay.
the application.
So you can type yes and container. Yeah. And secondly, if you know already, then where it's running? It's running in the container or running in the VM? Let's hear it from all of you. Dharmendra says container. Brijesh says container. Sivamani has already told container. 3 of 7 people are containers. Okay, others. See, I understand. That's what this asks. You don't need to feel anything. If you don't know, it's fine. I understand that people do not know, because we are so focused on the application that we don't realize the importance of knowing where it's running. So I understand that, and that's why I'm here, right? To make you understand what is important, at least. Okay, Ravi, that's fine. Okay, others? Okay, friends. Okay, I'm going to assume that we don't know. Okay, that's what I'm going to assume. So, friends, we should definitely know, first of all, because I'm trying to, I am testing one. Okay, Nikhil, yes, container and on-premise servers. Okay, good, Nikhil. So look at this, 4 out of 7 people are using containers, and that is the world. Okay, everybody is using container. You may not know it, but most of the companies are using containers because that offers cost optimization. First of all, that's the most important factor. And we talk about Docker, we talk about Kubernetes, we talk about auto scaling of Kubernetes. We go in detail about Docker and Kubernetes in this course. And we talk about deployment in the container, how architecture of Kubernetes, Docker, how it works, what is containers, and all those things, right? In detail, we cover. This course takes approximately 3 months to cover. Okay, it's a very vast course, and very vast course. Okay, we spend approximately 40 hours of live sessions. 35 to 40 hours of live sessions we cover in this course. Goes approximately 3 months. So one of my batches are getting over. So That's why starting with a new course, new batch. Right, friends? So that's very important. If you do not know, let's say you do not know, please find it out. Is your application running in the VM or running in the container? And we should, that's very important for the capacity planning, to understand these things. It's not just for the knowledge sake, because if you're a performance engineer, let's say tester, and you do not know, then how would you do capacity planning? How would you know the core RAM and load ratio? It's very important for you to know, to work as a performance tester engineer as well. Okay. Now we talk about automation, friends. We talk about how performance engineering fits in DevOps, the roles of a performance engineer in DevOps. And we talk about automation. We talk about Jenkins here in DevOps, and we talk about code deployment, automated code deployment, CI/CD pipeline in Jenkins, using Jenkins. Right. We take the example of GitHub, and Docker Hub, GitHub, and Jenkins. Maven, we talk about these things here. Jenkins file, we talk about these things here. We talk about a lot of AWS services, talk about databases, we talk about security services, we talk about networking, we talk about storage services. In this course, we talk about monitoring, friends. We talk about the importance of monitoring, observability. We take up Prometheus and Grafana and Elastic Stack. CloudWatch, which is AWS monitoring service, and Linux monitoring. Through Linux scripting, we can monitor the application. We talk about these things. As part of this course, we take up Java performance engineering. We go about understanding how the Java application, Java troubleshooting you should do. What are the importance of Java application? Like if you have been working as a Java performance engineer, understanding of the heap dump, what is shallow heap, retained heap, GC algorithms that we have, G1 GC, parallel GCs, right? And those things, CMS, understanding of those things, thread dump, GC, log analysis, heap dump. We talk about those things here. We talk about automation using Terraform and Ansible. Right. So this is the course, okay, and that's why we cover a lot of things, and we provide Java and Python recorded sessions. So we cover a lot of things, and that's why this course takes approximately 3 months. So we are starting this course, friends, from next weekend. Saturday will be a demo. I'll talk more about the course, how we have designed this course, what all we cover, how we cover, all those things. Next Saturday, friends, we'll go over that. I'm done, friends, for today. Any questions I can take it up, friends, for you?
Yes. So
Go ahead.
do you have recorded videos, right? Recorded course, right, for this one?
Yes.
Yes. And one more thing. Recently I was looking some video and all where it was saying like site reliability engineering agent, SRE agent, which was built by Microsoft. Okay. Will that agent help SRE engineers do their work in much better way, or else like it's gonna replace some of the, like you said, like L1, L2, L3, like the beginner SREs, it's gonna replace the beginner SREs positions?
See,
Like
all
what is
these
the impact of that?
automation, right? I got your question, what you are trying to ask. See, all these automation, it's all about automation, agentic AI agents, right? It's all about automation. See, we are moving towards automation, no doubt, right? And we have to, everybody talks about automation. It's not like first time we're talking about automation. We have been talking about from last 10 years, automate whatever possible. And that's why we should know Python scripting, cell scripting, we should know to automate wherever possible. So agentic AI agents, that Microsoft agent that you're talking about, it's all about automation. How, if an issue comes, see, if a CPU resource is happening, you should know, 4 or 5 regions, why it could happen. So you can give some criteria and you can code it and you can get things done through coding. If a response time is high, you know what all to look, what all to collect. But troubleshooting is something you cannot automate 100% because it is very subjective, application to application, problem to problem. You cannot just rely on those automation, whatever possible, because the issue in itself is a very different issue. Yeah, if you know that you're going to get this issue every time, the same issue, you have full confidence on your automation that this is going to fix it. So you always, the troubleshooting is something which is very difficult to automate. Yes, we are trying to automate a lot of stuff, but that has secondary level. First of all, you should know the basics. See, troubleshooting, automation is only helpful when you know the basics, right? Today, I'll give you a best example. Today, we know that there are a lot of Gen AI tools, Copilot, and we have Chat GPT and other things. It can help us write essay or some documentation, some presentation. But if you do not know English language, will that help?
No.
Do you understand my point?
Yes.
If you do not understand the English language itself, how much ever they help you write essay or presentation, will not be any meaningful to you. So first thing is that we should know the basics. Yes, if you have covered the basics, you know very much comfortable with these fundamental things. We talk about agents, we talk about automation, and it will keep on happening. A company will keep on developing some sort of automation. Even being an SRE team, you can think about if the issue keeps coming, if the issue is coming disk out of disk, you know what to do. You can write 4 or 5 scripts, 4 or 5 lines, and you can get your disk. It's all about that. It's all about getting things in an automated manner. You don't need the manual intervention for few of the standard problems. So it's about that, Nikhil. I hope I answered your question, Nikhil.
Yes.
Perfect. Any other questions?
And one more question, like it's a general, as you're like we have very good, like vast experience in IT across all the areas.
Yeah.
So what will be the impact of AI on IT on a whole?
See, we need to, if you don't want to get impacted, if you want to continue, yes, if you do not adopt AI or the way things are happening, your job will not be permanent, right? You cannot be assured that you'll have a job in IT. And it was earlier also. Earlier, I'll just forget about AI. If earlier cloud came and it automated a lot of stuff. Earlier, if you know, there were a lot of roles opening for DBAs, Linux admin. Do you find such roles now? DBA, Linux admin. Do you find such roles, Nikhil?
Yeah, in the like few days ago, I was having a call with one of my friend who is a DBA. He said that his position is at stake because the kind of automation that is being implemented, like he's an Oracle
Yeah,
DBA at the
right,
Oracle
right.
level. So he's saying that a lot of things are getting automated, and his position might not be that prominent in the future in the coming
Working
years.
in Oracle, being an Oracle DBA, he's at stake. Think about normal DBA and not working in Oracle. So because it's not about AI, Gen AI, it's all about cloud automation. If you know about cloud, I can create today. Earlier, you required a DBA to create a database, correct? Now, if I know cloud, I take up the course, I can go to the database and I can create any database of my choice without any DB intervention. All I just need is 5 minutes. I will create any database that you want. I can create Oracle, MySQL, Postgre. I just logged out. Let me just log in. I will just show you. So cloud has automated a lot of stuff. There were role like Unix admin, Linux admin. There is no such role now. There is no such role now. Every role has merged into DevOps. All those roles have become obsolete, and we call them as DevOps engineer today. And DevOps engineers are expected to know all those things. So the same way, right? Again, we have to adopt to the automation, and we need to use those automation and get yourself up and running with the world, with the expectations of the world. Because today the knowledge is not a problem. We should know the basic. Let's say I'll give you one example. Okay, let me just complete this example database I was showing you. I don't need to be a DBA to create any database, and I can select Oracle database, MySQL, IBM DB2, and I can just select few options. I can create database, and cloud will help me create. It's an automated way. Not just that, right? I can get third party, Mongo, Atlas, Astra DB, say Snowflake, and I can just take their subscription and they will help me. Like how they help Dynatrace or AppDynamics. If you take a paid subscription, they have experts joining and they can help you configure everything, dashboards and instrument, all those things, instrument your code, everything. So why do I need a DBA for this? If I can create a database and developer can write a SQL query, performance engineers can help write querying, optimize the query. Do I need a DBA? Think about it, right? Everything is automated. So same way, right? If you are into a profile which can be automated easily, right? For example, let's say QA profile, automation engineer working in Selenium, Java Selenium. A 2-year guy using GenAI tools can write a Selenium script. All I have to give is the website URL and put proper prompt, and I get the Selenium script with me. All I need to troubleshoot it. Yeah. So we need to use it. So it will reduce the gap between a senior 8 years and 3 years. If let's say both of you have a basic knowledge, let's say 2 developers, one senior, one junior, have a basic knowledge of writing the code, troubleshooting application. If a senior knows better, more. Now one is 4 year, one is 10 year. Now using this GenAI tools, a 4-year can write an optimized code. I can use GenAI tools and I can write an optimized code. And all I have to just use in my code base and get things going. So that has reduced the gap between a senior and a junior. That is what it has happened. So all we have to do, be on top of this, we should be automating it, and we should add and see how can we upskill ourselves. Being a developer, if a new developer, you should be into deployment also. You should be able to do troubleshooting also. We need to adopt the automation and get ahead of the curve, get ahead of the other people. And it has always been the case. 10 years back also, now also. I would take it this way. Okay. Yeah. I hope sounds good to everybody. Any other thoughts by anybody? Okay, perfect. That's all, friends, for today. Thank you so much. I hope we learned something. Can I get a thumbs up from all of you? We have learned something in this 1 hour. That was the whole intention. Thank you so much, everybody. We'll meet next weekend. Thank you so much.
Yeah, thank you.